Welcome back. So if you've done any programming at all, or even messed around with formulas and functions in a spreadsheet program like Microsoft Excel, chances are you've run into some errors. That happens to the best of us. And while these errors can occasionally be confusing, understanding the different types of errors you'll encounter and having a strategy for dealing with them can save you a lot of frustration down the road and ultimately help you become a better coder. So first up, among those types of errors, we have syntax errors. So syntax errors are mistakes in the structure of your code that prevent the computer from even being able to interpret it. These errors can be something as simple as misspelling a keyword, like the name of a function, for example. So here, I'll try to use Python to programmatically determine the data type of the number 42.11. But see if you can spot the error as I code. See it? Well, let's see if Python does. Okay, so since I obviously misspelled the type function, Python has no earthly clue what I'm talking about and throws an error. Remember, computers tend to be very literal-minded creatures and are very poor mind readers, with the possible exception of ChatGPT. Now, these errors can look a bit intimidating at times, but they usually have helpful information nonetheless. The key is to read through them calmly and critically, looking for any keywords that may offer clues as to what went wrong. In this case, for instance, we see that Python is throwing a name error, and that the name TIPE is not defined. In other words, Python is telling us, in its awkward, computery way, that it doesn't recognize the name of the thing I entered. And sure enough, that is the issue. I got the name of the function wrong. So if I just change that, now everything works great. Now, as another example of a syntax error, let's see what happens if I try to multiply 2 by 21, but conveniently forget how to do multiplication in Python. Once again, I get an error, and this time Python is nice enough to literally point an arrow directly at the culprit. In this case, X really does mark the spot, that being the X that I was silly enough to think would work for multiplication here. Now keep in mind, resolving errors won't always be quite this easy. But if you carefully read through the error and still can't figure out what went wrong, don't hesitate to look for help online by Googling the error message, or Binging it, or DuckDuckGoing it, or even ChatGPTing it if that floats your boat. So with that said, let's go ahead and fix this ugly error. And we're good to go. Now another, somewhat more subtle and insidious type of error is semantic errors. These are mistakes in the logic of your code that cause it to produce the wrong output, even though the syntax is technically correct. In other words, the computer is able to interpret your code, but it doesn't do what you intended it to do. So let's say I want to multiply 2 times 3 and then take the result of that expression to the second power. Let's take a shot at crunching that out. So I'll say 2 times 3 raised to the second power. Okay, so there are no angry error messages or arrows pointing at my code, and we get a sensible seeming result of 18. So I must be on the right track, right? Well, not quite. Remember, our goal was to multiply 2 by 3, then take the result of that to the second power. But 2 times 3 is 6, and 6 squared is 36. So while our code was technically correct from a syntax perspective, it wasn't actually doing what we intended. That's of course because I didn't use parentheses to override Python's default order of operations, which stipulate that exponentiation should occur before multiplication. So if I fix that, now we get the intended result. Now, of course, the problem with an error like this is that if we aren't specifically looking for it, it can slip right past us. Semantic errors are sneaky. So how best to avoid them? Well, unfortunately, there's no ironclad way to prevent these kinds of errors altogether. But carefully reading through your code an extra time, while keeping in mind exactly what you want it to do, never hurts. I also recommend testing the output of your code versus what you expect, as well as thoroughly testing edge cases in more complex programs. Okay, so up next, we'll expand our horizons to explore an especially useful sort of expression, involving text strings. I'll see you then.